Quotient rule. I didn't put a bodybuilder in there. Bummer. All right. Quotient rule. So that means division. So I used to say, write these out. 2 to the 5th, write them out. That's 2 to the 5th over 2 cubed. What happens here? Well, what was nice about divisions, they canceled. You line them up, boom, boom. He cancels him. And you're left with 2 times 2 is 4. But really what are you left with? You're left with 2 squared. Is there a rule here with the exponents? Sure. I can say 5 minus 3 is going to give it to me. So quotient rule says when you have that same base, again, it's only because they both have the base of 2, you divide exponents same base, you subtract the exponents. So jot that down, have it, pause it if you need to. All right, let's do some examples of this. So when I'm doing this, what is the base? Is it the same? Sure, the base is 2, so I'm cool. I'm good to go. 2 to the 11th divided by this, subtract them. 11 minus 6 is 5. Same base, my base is negative 4. That means I'm good to go. This is going to be negative 4 to the what power? 7 minus 4 is 3. And again, they both have a base of x, so I'm allowed to do this. They're going to cancel each other out. I'm going to be left with x squared. 5 minus 3 is x squared. Very cool. Do 3 and 12 have the same base? No, they don't. So they're just a fraction. So we just got to reduce them. 3 goes into itself once. 3 goes into 12 4 times. So 3/12 is the same as 1/4. So there's no subtracting or rules or weirdness here. It's just a fraction. Reduce it if you can. Not all times they reduce, but if you can, reduce them. And then I've got y to the what power? They are the same base. They are y. So 11 minus 5 gives me 6. Fantastic. Look at this monster right here. I love it. Again, they're not the same base. 6 and 2 are not the same base. So 2 goes into itself once. It goes into it 3 times. So it's 3 over 1, which is just 3. And then go through x to the what power? Well, 9 minus, remember there's a 1 if it's not written. 9 minus 1 is 8. 4 minus 2 is 2. 5 minus 4 is 1. You can put the 1 there or not. It's up to you. Very good. Excellent. Let's keep this flowing. More special case codes. I just want to make sure that you know that it's always to everything in there. So this is really, 2 times 2/3 times 2/3 times 2/3. So I know you've been expanding, but it's the same as 2 to the 3rd over 3 to the 3rd. You can cube everything on top, cube everything on bottom. It's got to go to both of them. So again, this is the same thing. This is x cubed over y cubed, or expand it out if you want, but it's getting everybody. So when you do something like this, everybody's getting cubed. So even everything on top is getting cubed. So some people like to think, oh yeah, that's 2 to the 1st power. 2 to the 1st cubed is 2 cubed, x cubed on top. And then what's on bottom, it gets cubed as well. So we just learned a power to a power. 2 to the 3rd is times and you get 6. So everybody in these parentheses is getting cubed on those. So I just want to make sure you got them all there. I think we got a little wisdom here. Oh, we had Kelly Fuchsias last time. Now we got Solicrates. Just like Socrates, he says Gimdos is awesome. Remember back, and it's actually section 1.1. It was the very first one. Gimdos. You remember we've got these, look at grouping symbols first. Exponents. This is multiply, divide, and this is add, subtract. It is awesome, Mr. Sullivan. You're exactly right. And it comes into what we're doing. When we do this, we need to do Gimdos. This is a huge shortcut. Basically, we've got 3 rules, and you're probably like, well, how do I keep them all straight? I've got the product rule. I've got the power rule. I've got the quotient rule. Well, here's how we're going to do them. Think about power rule, and let's do it with power rule. So when I have like a power to a power, 2 to the 3rd to the 4th, my power rule says this, exponent. I've got an exponent to an exponent. If you look at this, what is the rule here? If I circle this, if I have an exponent, I'm going to multiply. It tells me, Gimdos tells me what to do. Oh yeah, I know that's 2 to the 12th. How about this? What if I multiply 4 cubed times 4 to the 5th? Oh, I don't remember the rule. I know they have the same base of 4. What do? Check this out. Gimdos tells me. When I multiply, what do? I'm going to add them. So that's 4 to the 8th. Super cool. So there's power rule. There's product rule. What about, does it work for division rule? 4 to the 9th over 4 to the 5th? Sure. What's the rule here? Oh, I have a hard time remembering that rule. But check it out. Gimdos tells me. What am I doing? I'm doing division. What happens when you divide? Oh, I meant to have that different color. Bummer. You subtract. So this is really 4 to the 4th. So Gimdos is awesome. It tells me what to do. So this, remember this. This is great. A friend of mine, Ms. Kless, showed this to Mr. Sullivan, who showed it to me. Awesome. Very cool trick. Thanks, Ms. Kless. Appreciate it. Next one. Gimdos it up. So here are the rules. I don't remember. But what am I doing here? And there he is again. It is awesome. Thanks. I'm multiplying. What does multiply mean? Multiply means add the exponents. So if they have the same base, add them together. That's y to the 10th. And then I'm going to say 5 times 6 is 30. Super. How about the next one? GIMDOS, again, is awesome. Thank you, Ms. Sullivan. I've got a grouping symbol with an exponent. So if you want to circle the thing, you can. You've got a grouping symbol with an exponent. So what do? I multiply. So really, it's going to be y to the 12th, x to the 20th. 5 times 4 is 20. 3 times 4 is 12. What happens here? Remember, this is like a power of 1. So this is really 4 to the 4th power. If you want to expand that out, you can't use it. 4 times 4 is 6. So 4 to the 4th power, if you want to multiply it out, you can say it's 256, 256, x to the 20, y to the 12. Either way is cool, except either one of those answers, you're good to go. Love the GIMDOS. Ah, there it is. Humorous repetition. GIMDOS is awesome. I've got division, so what's the rule? When I divide, I'm going to subtract. Now again, start with this fraction. I'm just reducing it. They're not the same base. Does 5/7 reduce? No, 5 doesn't go to 7, so I'm going to leave it alone. 5/7. But I'm going to go ahead and do the subtract like it says. 8 minus 5 is 3. 5 minus 3 is 2. Super. One more page. Let's bring the pain. Here we go. Oh, I got GIMDOS because we're going to have to keep referencing it. Where do I start? Just start with GIMDOS. Start with grouping symbols. Do I have grouping symbols? If I do they have an exponent? If I do, I need to multiply them. So I do have a grouping symbol, and it is to an exponent, so I must raise it. So this is really going to be, remember, this is like a 1. 2 to the 1 to the 3rd. 2 to the 3rd. A to the what? 3 times 3 is 9, because I know I'm multiplying. B to the 4 to the 3rd is B to the 12. Then I'm going to multiply that bad boy by what? 4ab to the 5. Super. So let's go ahead and multiply. What is 2 to the 3rd? 2 times 2 is 4 times 2 is 8. So I'm looking at 8, a to the 9th, b to the 12th, times, you can do parentheses or dot, 4ab to the 5th. So what does the top really give me here? Let's say what's going on top here. I'm going to do numbers. They're not the same base. So 8 times 4 is going to be 32. Oh, how do I know what I'm doing when I multiply? When I multiply, I'm adding. So a to the 9th, a and a, so that's really like a to the 1. I'm going to say a to the 9th plus 1 is a to the 10. And b and b to the 12th plus b to the 5th, b to the 17th. So that's on top of your fraction. 32, a to the 10, b to the 17th. That's all over the bottom. Just bring it on over. Nothing going on down there. So what do I do when I divide? Divide says I subtract, so let's divide them. Does this reduce? Sure, 32 goes into it once, goes into that twice, so that's really just a half. What is a to the power of? Well, I subtract them, because it tells me to subtract. 10 minus 5 is 5. Subtract your b's, you get 14. So great little rule on that GIMDOS. Remember that, have that, and you'll be fine. Nice little trick. Got another math fail on... What's next, though? Can I keep this pattern going? Sure, I can go 2 to the negative 1. 2 to the negative 2, and 2 to the negative 3. Are you for seriousness? Yes, I am for seriousness. Let's check this out. What's the pattern doing? It's cutting in half every time I go up. So what's going to happen if I can... These are all going backwards by 1, 3, 2, 1, 0, negative 1. So what's going to happen? I'm going to cut this in half. This becomes 1/2. Oh my goodness. Can I cut a half a half? What is 1/2 of a half? It becomes 1/4. And what is 1/2 of 1/4? It is 1/8. Oh my goodness. So what's the rule here? What's going on? Well, let's check it out. This is 2 to the negative 1 equals 1/2. So what does that really mean? This really means I took that 2 and moved it to the bottom. It is really 1 over 2 to the first power. How about this one? This is 1 over 2 squared. 2 squared is 4. So this negative is moving it to the bottom of the fraction. 1 over 2 cubed. So if I want to get rid of that negative, I move it to the bottom, and it's a positive. So negative exponents flip it to the bottom. Holy cow. So if I had something like this, x to the negative 5, what does that mean? Well, I want to rewrite this without negatives. I'm going to put 1 over x to the 5th. So who knew Sub-Zero was really a math character that whole time in Mortal Kombat, doing his fatalities and things like that. Awesome. Let's check it out. Can we rewrite these only using positive exponents? Let's see what we got here. So maybe you need to write these down. So 2 to the negative 3rd, what does that mean? It means 1 over 2 to the 3rd power. Awesome. And it says use exponents, so we're good to go. If you want to multiply that out because you were interested, 2 to the 3rd power is just 2 times 2 times 2. So that's 1 over 8. Awesome. And we just, holy cow, these are the same examples off the last page. I just made those up too. X to the negative 5, this would be x to the 5th. Excellent. We can't write that anymore. Hopefully these are new examples. We got something new? Yeah, sure. Tries 3 to the negative 2. What happens here? It moves it to the bottom. It is 1 over 3 squared. How about this? What is the negative 4? What is the base of this power? The base of negative 4, so the base of this case is y. It's not the 2, it's just the y. So the power of this is negative 4 only for that base of y. So the 2 is just chilling. He stays right there. What's going to happen? My y comes to the bottom. This is y to the 4th. And really the way we like to write this is to multiply it out. What is 2 times 1? If the 2 stays on top, the y ends up on bottom. So you need to express it like this. This is the answer. But that's what's happening here. And it's just like multiplying fractions. 2 is like 2 over 1. Multiply across the top, multiply across the bottom. Or just think about it. The y is the only thing being raised at negative power. It's the only thing moving to the bottom. Fantastic. We're killing it. Let's go to the next page.
All right, let's take a look at rewriting these using positive exponents. So I've got this big, long thing here. How do I change this? Well, I'm looking for these negative exponents. If you want to think about this, you're saying 2x squared, y to the negative third, remember, is 1 over y cubed, z squared. And this is all multiplication. That is technically right. It just looks weird. Essentially, whatever happens when you have this negative, you're going to move it to the other side of like a fraction. So like 2x squared will stay on top. Y to the third moves to the bottom. So we're going to move this to the bottom. That's what that 1 over y cubed is. The z squared stays on top, so it looks like this. This is how I want to see it written. Something like this. So you're going to move this to the bottom of a fraction. Sometimes you got to create a fraction. Sometimes you don't. So that is the correct answer here. Same thing over here. I already have a fraction. Who's going to move to the bottom? We'll look for the negatives. We've got negative 2, negative 3. Positives stay the same. So what is this going to equal? My 1 stays on top. My 4 is on bottom. The a squared moves to the bottom. And when you move it to the bottom, it takes its sign. So it becomes a squared. That a 2 is positive. B to the 5 stays on top. C to the third stays on bottom. It moves to the bottom because of the negative. So we're going to kind of rearrange where these things are. That's the answer. Fantastic. So moving on, it gets a little bit trickier. What happens when we start trying to do some of our different operations? Like in this case, what am I doing? Well, I have a grouping symbol, yeah? I've got these parentheses. Some people do PEMDAS. We got grouping, GIMDAS. What is my rule with a grouping symbol to an exponent? I have an exponent. It means what? If I look at GIMDAS, if you write it this way, exponent means multiply. So when I do this, this is going to be what? X, this is 3 to the 1. And then 1 to the 2 is 3 squared. This is negative 3 to the 2 is negative 6. 0 times anything is 0. So that's still y to the 0. And really, we know y to the 0 as what? Y to the 0 is just 1. So you can put times 1, or I'm not going to put anything. If you times by 1, doesn't change a thing. And can I simplify this? Sure. What is 3 squared? 3 squared is 9. X to the negative 6. So first we're going to do our things. Then when we're finished, we're going to rewrite it. So go ahead and do all our operations. In this case, we had to simplify it. Then you can move the exponent to the bottom. So that moves it to the bottom of the fraction, or 9 over x to the 6th. Very, very nice. Let's take a look at the next one. Okay, I got a lot going on here. Looks like I'm multiplying these two things. So I'm going to multiply this times this. When I multiply, what do I do with my exponents? Well, if they have the same base, I'm going to add them. So m to the 4th, m to the negative 3 gives you m to the 1. How about n? n to the 1st, I'm going to add it to n to the negative 5. This is n to the negative 4. And remember, my coefficients are different. What is just 2 times 3? I can go ahead and multiply those out and say 2 times 3 is 6. So this is only for when we have the same base and we're doing the powers. Base was m, base was n. All right, fantastic. Now, once you have that done, can you rewrite it? Sure. Who's going to move to the bottom? The negative is. So everybody else is going to stay on top. You can write 6m to the 1, or you can just leave it like that. And when I move that negative 4 to the bottom, it makes it positive. So these are written with positive exponents. So please do the rule first. Then after you've done the rule, go ahead and get rid of that negative exponent.